This is lesson 9.4 with a focus on dividing rational expressions. In the previous 9.4 lesson, we talked about simplifying and multiplying rational expressions. And if we can do that, then dividing is just one extra step. Let's just think about what happens when we divide two fractions, because after all, a rational expression is just a fraction. Okay? So when we divide two fractions, what we're going to do is we're going to take that second fraction, and what we do is flip it upside down. So instead of 1/2 divided by 3/4, we have 1/2 times 4/3. And when we do that, we change the division into multiplication. And then we just multiply straight across. We get 4 over 6, and of course we're going to simplify to 2/3. So now let's see how this works when we have two rational expressions. I'm going to take my second fraction and flip it upside down. So instead of saying 5x squared divided by this expression, we're going to have 5x squared y over 2xy cubed times that whole expression. So once it's flipped, I'm going to multiply straight across. I get 50 x squared y squared over 12x to the 4th y to the 5th. And now I'm ready to simplify all of my numbers and all of my variables. And when I do, I get 25 over 6. And then when I subtract my exponents, I get x squared. And then when I subtract my exponents for y, I get y to the 3rd. And they go on the bottom because that's where the biggest exponent started. So that's where it simplifies to. So right here in red, this is my final answer. Now let's take a look at what we have to do when we have an expression that needs to be factored. Just like I did in the other example, before I even start to factor, I'm going to go and I'm going to flip my second expression. Once I have it flipped, then I'm going to go and I'm going to factor every single one of these expressions. If you struggle with factoring, go back and find my podcast of the factoring review for this section. It should be called Chapter 9 Factoring Review or 9.4 Factoring Review. I'm going to factor these pretty quickly. And once I have everything factored, I've looked for greatest common factors, trinomials, any other special types of factoring. Once I have it factored, now I'm ready to go and cross out the things and simplify, because I know that when I multiply it becomes one great big fraction. And so I can start crossing out. I have an x minus 4 and x minus 4, x minus 2, x minus 2, and I have this single x. Those will cancel, and I'll find that all I have left is 5/3. Here's a similar problem. I'm still dividing, but this time I'm dividing by an expression that's not a fraction. It's not rational. So what I need to do is I need to put it over 1 and turn it into a rational expression. Then it's easy to see that if I have division, I'm going to flip my division. And now that I've turned it into multiplication, now I'm ready to factor. Once I have it factored here in red, now I can go and begin crossing out the factors that are in common in the numerators and denominators, because again this becomes one big fraction. So the only thing it looks like I can cross out is this 2x plus 3, which is going to leave me with 3x minus 1 in the numerator and then 6x cubed in the denominator. Now let's take a look at this example. There are 3 expressions here, and I want to point out that when you have division or when you have multiple expressions being multiplied or divided, it's really important to remember that only the expression that follows the division sign gets flipped. So if these were in a different order, I would flip only the one that immediately follows the division sign, or any expressions that immediately follow any division signs. Those are the only ones that get flipped. So here, let's go ahead and flip it. And now that it's flipped, the only thing that looks like can be factored is the 9x squared minus 25. All the other expressions are already completely factored. There's no greatest common factors, nothing else to break down. So I'll go ahead and just factor just this denominator here. It's a difference of squares. So I'm just going to real quick write it down just under that denominator. Okay, and now I can go and I can start crossing things out. So I have an x plus 5 and an x plus 5, 3x minus 5, 3x minus 5, and the only things I have left is an x in the numerator and a 3x plus 5 in the denominator. And there is my simplified expression. Now the last kind of example we'll discuss here in this lesson is something called a complex fraction. And a complex fraction is nothing more than a fraction within a fraction. So here we've got this numerator over this denominator. And so we have two fractions within a fraction. And this looks scary, but really we need to remember that fractions are division. So what we want to do is we want to rewrite this as the numerator divided by the denominator, and it'll look a little bit like this. So now it's not so scary, because we know that when we see division, all we have to do is flip that second fraction, and it'll look like this. Once we have that second fraction that follows the division sign flipped, then we're ready to factor and cancel. So now that we have it factored here in red, I can cancel anything that's common in both the numerators and denominators. I have a 2 and a 2. I have an x plus 6 and an x plus 6, and that looks to be all I can cancel. So now I'm going to write down what I have left, x times x minus 5, all over, and I have 2x minus 6's. That's okay. So there is my simplified complex fraction.
Made with Doodlecast Pro.